Hi dear students, this is Shivakrishna. Today I am going to discuss January 2023 Shift 1 JEE Mains question paper. These questions which are appearing on the screen are completely memory based. So those who have appeared in the exam, those big knowledge based questions only. Now let us see one by one question. The first question, that is coordination compound lesson. That is pentaamine chlorido cobalt chloride. This is the complex they given. In this question they are asking about primary and secondary valencies. Generally this question is based on concept of Werner theory. Werner classified the complex into two things, that is primary valency and secondary valency. That secondary valency refers to coordination number of the central metal atom, and the primary valency, that is the number of ionizable ions in the ionizable sphere. According to this, let us see CONH3 taken 5 Cl plus 2 and 2 Cl minus. This is the non-ionizing sphere and this is the ionizing sphere. The number of ions which are ionizing here is 2. That's why the primary valency is 2, and the coordination number, this coordination number will indicates the secondary valency. Therefore, the secondary valency is 6. This is the simplest question, I think so, in the coordination compound. Now go for the next question, students. Second question. This is tetrachlorido cobalt 2 ion. They given the electronic configuration like e power m and t2 power n. Then calculate m plus n value, where n is the number of unpaired electrons, m is nothing but number of electron in the easy set of orbital. Let us go for the complex. CO Cl4 minus 2, then chlorine is minus 4 and the cobalt is plus 2. Now here the cobalt charge is plus 2. Cobalt plus 2 electronic configuration 3d7 and 4s0. Now here the given chloride is a weak field ligand, friends. Then the configuration become like this. Then it should be the sp3 hybridization. That means that tetrahedral geometry. Whenever the tetrahedral geometry, the crystal field splitting will be EZ and T2Z. EZ set and T2Z. The number of electron 1, 2, 3, 4, 5. Since here the chloride is a weak field ligand, then electrons are paired first EZ as well as T2Z. Later they get paired up. So according to the given configuration, EZ 4 and T2Z 3. See friends, here the EZ have 4 electron and T2Z has 3 electron. So according to the given thing, m is equal to 4 and the number of unpaired electrons in the T2Z set is 3. That is why the m plus n value becomes the 7. This is the way we can easily solve the problem. That is, this simply depends upon the logic is the given chloride ion is a weak field ligand. That is the simple logic we have to remember, and based on that we have categorized the geometry into tetrahedron. That is why EZ set comes down and T2Z set goes up. We'll go for the next question, students. Yes, the graph of X-ray frequency power n versus atomic number z is a linear, find the value of n. Yes students, this is the Moseley's equation. That is, whenever metal surface is irradiated with cathode rays, some unknown rays are released, those are X-ray. Okay, now the frequency of X-ray versus what is that? Atomic number. He proposed an equation, already you know students, root nu is equal to A into Z minus B. Here nu is the frequency of the X-ray produced and Z is the atomic number of the metal is used. Now base A and B are the constant. Based on that, root nu is directly proportional to Z. That is nu power 1 by 2 directly proportional to Z. Yes, we got the same equation whatever they asked you. That is frequency power n versus of atomic number. Therefore, the n value should be of or plus 1 by 2. That is the question, students. Now you go for the next question. Next question is, the wavelength of the first line of the Passion series is 720 nanometer, and calculate the wavelength of the second line in the Passion series. Already you know, student, this question is completely based on atomic structure, hydrogen spectra. You know how the hydrogen spectra is present. S, n equal to 1 ground level, n is equal to 2 first excited state, n equal to 3, n is equal to 4, n is equal to 5, n is equal to 6. The electron, wherever that or any excited state, if it comes to ground level, that is called Lyman series. If it comes to second level, is called Balmer series. It comes to here Passion, Lyman, Balmer, Passion, Brackett, Fund and Humphrey series. If the electron gets de-excited from the excited level to ground level, that is one first energy level, that is called Lyman. This is called Balmer series. This is called Passion series, like this. So the Passion series, if the electron is in more than the 4 or more than 4 excited state, if it comes to ground, what is that? Third energy level. If the electron is in either 4th energy level or 5th energy level or 6th energy level, if it comes to the 3rd energy level, the lines appear are called Passion series. According to that, you see this is the first line and this is the second line and this is the third line in the Passion series. So the wavelength of the first line of Passion series, generally to know for every wave, what is that wavelength of every line in the hydrogen spectra is given by 1 by lambda is equal to R into Z square into 1 by N1 square minus 1 by N2 square. Is it right, students? Where R is the Rydberg constant, Z is the atomic number of the uni-ion species, and N1 and N2 are the energy level. N1 is the lower energy level, N2 is the higher energy level, and lambda is the frequency of the wavelength of the line which is appeared. Now let us go for the first one. Wavelength of the first line of the Passion series. The first line is 423. First line of Passion series is 423. Then 1 by 720 nanometer is equal to R into, we was not mentioned any atom or the ion which is going to be detected here, but there is no problem for us. We have to write Z square and 1 by 3 square minus 1 by 4 square. This is the equation 1, students. If you change that also, you can do anyway. Yes, 1 by 720 is equal to R into Z square into 1 by 9 minus 1 by 16. That becomes 1 by 720 is equal to R into Z square into 16 minus of 9, 7 by 9 into 16. Let us say this as equation 1. Based on that, then calculate the wavelength of the second line of the Passion series. Now wavelength of the second line is equal to R into Z square into 1 by, that is second line. This is from 5th to 3rd energy level, 1 by 5 square. Let us say this as equation 2. Now divide that equation 1 by 2. Now if you do equation 1 by equation 2, then you can calculate lambda 2 value is 492.1875. After doing this equation 1 by equation 2, this r gets cancelled, z square cancel, and the 25 and that is 9. 25 minus of 9, after the calculations you are getting lambda 2 value is 492.1875. What is the nanometer? They given the units in nanometer. Okay na students? Now go for the next question. Yes students, this is the chemical bonding based question, that is find the correct order of covalent character. You know students, Fajan rules. What the Fajan rule says that? What the Fajan rule says that? Yes, as the cation size, as the cation size decreasing or anion size increasing or charge on cation and anion, charge on the cation and anion are increasing, as the cation size decreasing or the anion size increasing or the charge on the cation or anion increasing, who is increasing? Covalent character increases. And what is the fourth rule? Pseudo electronic configuration, pseudo inert gas configuration has more covalent character than what is that nana octet configuration. Then based on that, Kf and Ki, when I compare Kf and Ki, here K plus is the common, fluoride ion, iodide ion, fluoride to iodide, size of anion increases, that is why covalent character increases. Second point, Cu, Cl and NaCl, here chloride is the common, no distinguishable, and here is the copper is +1, here is the sodium +1. Copper +1, that is 3s2, 3p6 and 3d10. Na plus, that is 2s2, 2p6. If you see that here is the 18 electronic configuration, here is the 8 electron configuration, therefore 18 electron configuration has more covalent character than that of what is that 8 electron configuration. It is the Fajan rule. Therefore covalent character CuCl has more than that of NaCl. Now let us go for the lithium fluoride friends. LiF and Kf. Here fluoride ion is the common, there is no distinguishable thing here. Li plus and here is the K plus. You see that student, as the cation size decreasing, yeah, potassium and lithium. Lithium has the lesser size, that is why it has the more covalent character. So because of these factors, one is anion size bigger and second is octet rule. Rather than octet rule, pseudo octet configuration has more covalent character and lithium has the smaller size than the of potassium, that is cation size decreasing, covalent character increases. These are the points regarding to the what is the friends, what is correct answer of the fifth question. Okay, now let us go for the next question students. Yeah, freezing point of the solution is less than that of the pure solvent. He given the statement itself. There is no statement regarding directly this answers. That means which of the following statements are correct? By using this statement, we have to draw which statement is correct. Now let us see one by one. Freezing point of the solution is less than that of the pure solvent. Yes, absolutely. And now vapor pressure of the solution. What is the meaning of freezing point? Yeah, the temperature at which vapor pressure of the solid become equal to liquid solvent. The temperature at which vapor pressure of the solid solvent is equal to liquid solvent when they are in equilibrium. When they are in equilibrium, you call that as a freezing point. So automatically you said vapor pressure of the solution is lesser than that of pure solvent. Yes, absolutely. Why do they so? Let us see. Here is the solvent. Okay, in this one only the pressure is due to surface molecules. The surface solvent molecule gets evaporated, when they hit on the surface, they create some force on the surface. Force per unit area, you call it as a pressure. So the surface molecule gets evaporated, and when they condenses, they create some pressure on the surface. You call that as a vapor pressure of the solvent. Let us go for that. If you add some solute to it, let us add some solute to it. Because of the addition of some solute to it, what happened? Some of the surface molecules are occupied by solute molecules also. Some of the surface molecules are occupied by solute, non-volatile solute. I am saying non-volatile solute. So as the number of surface molecules are decreasing, as the number of solvent surface molecule decreasing, vaporization decreases, automatically vapor pressure also decreases. What is the reason, friends? Why do that vapor pressure of the solution is less than that of pure solvent? Because as the solute adding, non-volatile solute adding, the number of surface molecules are decreasing, automatically the vapor pressure also decreases. That's why the given statement A, vapor pressure of the solution is less than that of pure solvent, is a correct statement. Now let us go for the next thing. Vapor pressure of the solution is greater than that of pure solvent. Just now we discussed about that. And number 2, only solvent molecule will freezes. Yes, while the freezing occur, only the solvent molecule gets freezes, not the, what is that, Nana? Solute molecules. If it is the liquid solution, there is a chance to both gets what is that? Solidifies, but it is the non-volatile solute. The meaning is that, that's why A and C is the correct statement for the given question. This is based on the solutions chapter. Now you go for the next question, student. Yeah, for which of the following aqueous ion the spin only magnetic momentum is 3.87 Bohr magneton? Again the question is from coordination compound lesson. Everybody, I think you can say this question as a coordination compound as well as for the D and A black also, because both having the same magnetic momentum. That's why the magnetic momentum formula based question. Already you know what is the magnetic momentum formula? Under root of n into n plus 2 Bohr magneton, where n is nothing but number of unpaired electrons. Number of unpaired electrons. Yeah, whenever the number of unpaired electrons are 3, it becomes 3 into 3 plus 2 Bohr magneton, that is root 15. Root 16 is equal to 4, friends, and root 15 is nearly 3 point something, let us say 3.87 Bohr magneton. Therefore, in the given ion, there should be 3 unpaired electron. Then only the magnetic momentum should be 3.87. So let us go for one by one example. Let us say titanium, scandium and titanium 22. That is 3d2 4s2, and they given titanium plus 2, then it become 3d2 and 4s0. So here the number of electrons are 2 only. That's why there is no chance to get root over 15 or 3.87 Bohr magneton. Next, go for another one, students. V plus 2, that is vanadium, scandium, titanium, vanadium. Vanadium is nothing but, that is 23, students. That is vanadium plus 2, that is 3d3 and 4s0. Yes, friends, that is a aqueous solution, that is a weak field ligand, and then there is no problem. The number of unpaired electron 1, 2, 3. That's why 3 unpaired electron, there is a chance of 3.87. That is why the answer given is V plus 2 is the correct answer for the given option. Okay, now friends, now let us go for the next question. Yes, correct order of strength of hydrogen bonding in the following. Actually, this question we should take under chemical bonding chapter, we can assume, because this is comes under hydrogen bonding application. Okay, we are studying what is the types of hydrogen bonding and what is the hydrogen bonding. Now the question is based on application of hydrogen bonding, or we can assume the same question comes from hydrogen compound lesson also, because water is there in the hydrogen compound lesson. So according to that, we know that whenever you take what is that ice, that is a tetrahedrally hydrogen bonded molecules are present like this. See friends, like this, each water molecule tetrahedrally hydrogen bonding with one hydrogen bonding, second hydrogen bonding, third hydrogen bonding, fourth hydrogen bonding. Like this, tetrahedrally 4 surrounded hydrogen bonds for each one molecule of water, which will be present in ice. Already you know, while the ice melts, these bonds, intermolecular forces gets broken. That's why it gets into liquid form. Likely, my ice also, while you are heating more than 4 degrees centigrade, the hydrogen bonds gets cleaved off. That means that the ice should have more hydrogen bonding rather than that of liquid water. Automatically, if you take impure water or salt water like that, between the water molecule, the impurity may comes and the number of hydrogen bonding may decreases. That's why it should be the answer. So, ice has more hydrogen bonding than liquid water, which has more hydrogen bonding than impure water. That's why the answer should be BAC. Yeah, BAC is the correct option for the given question, friends. Now let us go for the next question. Yes, how many reactions are non-spontaneous at 300 Kelvin for independent reaction of delta H and delta S values are given? You know friends, this is the question from thermodynamics chapter. Here, according to the thermodynamics, the delta G is less than 0. Delta G less than 0 or delta G is negative becomes spontaneous. But he said non-spontaneous. How many reactions are non-spontaneous? The non-spontaneous stands for delta G should be greater than 0. If delta G equal to 0, the reaction is in equilibrium. So, delta Z should be greater than 0 or is equal to positive for the non-spontaneity. Let us apply the equation to here. How to calculate delta G, sir? Delta G and delta H and delta S. Free energy change, enthalpy change and entropy change are interrelated by a equation. That is delta G is equal to delta H minus T delta S, where they given delta H value, they given delta S value. Please cleanly observe everybody. They given kilojoules. Easier friends. Here is the joules. Here is the kilojoules. Here is the joules. The students are doing mistake here only. While applying joules or kilojoules, I have to verify. Let us say case 1. I am applying the case 1. Delta G, delta H minus 25 joules minus of temperature 300 into minus 80. That is friends, minus into minus plus 25,000 minus what is that? 24,000. That becomes overall value become minus 1,000. That is delta Z less than 0. That is a spontaneous reaction. So it should not be the answer. Second case, you take the case 2 students. What is that? Delta G is equal to 25 kilojoules again. That is the positive value. Minus into minus plus 300 into 50. The overall value become positive. So delta G is positive. So this should be the non-spontaneous. Likely students, let us go for here. Third option or case 3. Delta Z again is 22,000 joules, 20,000 joules and minus temperature 350 joules. Here is minus into minus 50, but here they given positive delta. What is that? Entropy change. That is 50. So 5 3s are 15,000. That is again delta Z is positive again or greater than 0. 22,000 plus minus 15,000. That is 7,000 is a positive value. So again it should be the answer. That means the question maybe comes as an integer. That means how many of the reactions are non-spontaneous. That's why answer may be integer question. Next, delta Z, case 4 you take, students. That is delta G is equal to minus 22,000 joules minus 80 into 300. 8 3s are 24. Again total value is negative. Here the delta H value negative and the delta S component also be negative. The overall is a spontaneous, that is less than 0. Therefore, it is a spontaneous, but the question it comes as non-spontaneous. That is the reason why the answers are only option 2 and option 3. Therefore, if it is an integer question, the answer is 2. Let us go for the next question, students. Since these all the questions are completely knowledge of the memory based questions of the student who have appeared in the exam. Now, buffer solution, pH is 5 and prepared by a mixing of 25 ml 0.2 m acetic acid, sodium acetate, and 25 ml of 0.02 m acetic acid. Then he asked to find out Ka, acid dissociation constant of acetic acid. But the value also they given x into 10 to the power of minus 5. We have to express the answer in terms of x into 10 to the power of minus 5. Already you know, students, what is the buffer? That is their simple buffer, acidic buffer and basic buffer. So the solution which resists the change in pH even though addition of either acid or base to heat is called as buffer solution. In that we are discussing about acidic buffer solution. Acidic buffer means weak acid and its salt of strong base. Weak acid and its salt of strong base. Let us given that acetic acid. Yeah, acetic acid is a weak acid and sodium acetate is the salt. It is the salt of sodium hydroxide and acetic acid. Therefore, the given acetic acid and sodium acetate solution is a acidic buffer. Whenever the acidic buffer is given, how to calculate pH? pH is equal to pKa plus log of equivalence of salt concentration by equivalence of acid. Yes or no, students? Now the given pH, already they given the pH value 5 and the pKa value we have to find out, and log of the equivalence of the salt given 25 into 0.2 by 25 into 0.02, both are cancelled and this becomes the 0.01 become log 10. Then 5 is equal to pKa plus of log 10. Log 10 means 1, then pKa is equal to 5 minus of 1, that is equal to 4. Whenever the pKa is equal to 4, friends, then Ka is equal to 10 to the power of minus 4. pKa is equal to minus log of Ka, then Ka is equal to 10 to the power of minus 4. They given 10 to the power of minus 5 as the factor. Then I have to write that Ka is equal to 10 into 10 to the power of minus 5. Then the value x should be 10 is the answer. Got the point, everybody? This is the way we have to solve the question, and actually this is the formula based question. If you know what is the meaning of acidic buffer, okay, then you can easily catch the point regarding this question. Now you go for the next question, student. Yes, this is metallurgy, that is refining techniques. Okay, now already you know what is the refining. Impure metal to pure metal, that conversion you call as a refining process. Generally the zone refining process is used for metallites, that is silicon. This is completely memory based question. Now electrolysis process we are applying generally for aluminium. If you don't know, you go for the next option. There is a chance to get the answer. Now reverberatory furnace, you know reverberatory furnace, and we have to use for blast furnace. For A is R. Where is the option? A is R. Already you know answer. Zone refining is R. Now you go for the second one. What is that? Q. What is the Q? Electrolysis is aluminum. Now see, reverberatory furnace is for S. Yes. Next, blast furnace we are using for iron extraction. That is, the iron obtained is the pig iron. That is the composition of iron and carbon, that is the will be different, pig iron, wrought iron, like that we have. So the reverberatory furnace is for copper and blast furnace is the extraction of iron. This question is completely based on the memory of the student. Now let us go for the next question, student. Yes, how many statements are the correct regarding to the Arrhenius equation? Actually this question came from our chemical kinetics chapter. Chemical kinetics. Here, what is the effect of temperature on the rate of reaction? We have explained based on this equation, that is K is equal to A Arrhenius constant and e power minus EA by RT. This is the temperature coefficient. Let us see the slope of the graph between ln K versus 1 by T. So apply logarithm on both sides, students. ln K is equal to ln of total A into e power of minus EA by RT. You know log AB is equal to log A plus log B. Then ln of K is equal to minus EA by R into 1 by T plus ln A. Let us see y is equal to minus mx plus of C, where the slope, negative slope, that is minus EA by R. Yes, the given is the correct. The slope of the graph between ln K versus 1 by T is the given minus EA by R, where EA is the activation energy, R is the gas constant. On increasing EA, the rate constant decreases. What is the EA? Activation energy. Let us see, students, R, that is the reactant and the product. For every reaction to occur, they must pass over by a high energy transition state. Say yes or no? According to the collision theory, the reactant molecule gets collide together and produces a high energetic state is called transition state. This is the energy of the reactant. Now the extra energy required by the reactant to cross over the transition state is activation energy. So as this gap is more, the activation energy required is more, the reaction becomes slower. So on increasing the activation energy, the rate constant decreases. Yes, rate is directly proportional to rate constant. So indirectly rate constant will decide the rate of the reaction. So as the EA value, as the activation energy value increasing more, the reaction becomes slower. That is why the given statement again is the right. On increasing the temperature, temperature coefficient decreases. Just now I said, na students, this is the temperature coefficient. As temperature increasing, automatically the temperature coefficient value become decreases, na? Yes. On increasing activation energy, fraction of molecule crossing energy barrier increases. Same point, just now I said. On increasing activation energy, fraction of molecule crossing energy barrier decreases. Why? As the more activation energy, they cannot easily get the transition state energy. That's why this should be the wrong one. On increasing activation energy, fraction of molecule crossing energy barrier decreases. He said increases is the wrong word. That's why the 1, 2, 3 statements are the correct regarding the question. Okay, na student? Now let us go for the next question. 5 grams of sodium hydroxide is mixed with 450 ml of deionized water from stock solution. What volume of the stock solution is used to prepare 500 ml of 0.1 m solution? Actually, he was not mentioned any molarity, and indirectly the given molarity of the solution. Okay, to this solution, this is the 450 ml 5 grams sodium hydroxide solution to become 500 ml 0.1 m sodium hydroxide solution. Okay, how much volume is required? Simply student, it is a dilution problem. M1 V1 equal to M2 V2. Initial molarity. Molarity you know, weight of the solute by molecular weight, gram molecular weight into 1000 by 450, which will give molarity of the initial solution. Volume, I don't know. What volume of the stock solution is used to prepare this? He is asking what is the volume to get this one. Indirectly, they given, first of all, they given molarity of the solution. Now 500, sorry, 0.1 into 500. After doing so, V1 is equal to 0.1 into 500 into 40 into 450 by 5 into 1000. Over students. Simply you can calculate the value. V1 you get 180 ml. After doing the calculation this. Yes or no? So the stock solution, initially the solution is 180 ml, having the molarity this, while diluting to what is that 500 ml 0.1 MnAOH. How much volume is required? That is what is the stock solution volume? That should be 180 ml. After diluting it become 500 ml. Understand students? Now go for the next question. Yeah, this is the question. Organic chemistry, that is carbonyl and its carbonyl compounds. Let us see the students' question. This is the KCN. They given that H plus first attacked here. Here the Cn minus undergo nucleophilic addition. They will get chlorine, and here is the Cn and OH. This H plus is for the reaction catalyzing purpose. The Cn minus do nucleophilic addition, we are getting the compound. Some students, why do that given chlorine? Some may be, what is that, think that the Cn may get a nucleophilic substitution, but it is not possible. Even the withdrawing group is present, because it is present meta to the chlorine, there is no chance of aromatic nucleophilic substitution. Followed by they given 2 equivalents of methyl magnesium bromide. Yeah, why do they given 2 equivalents of methyl magnesium bromide? Is 1 methyl magnesium bromide. 1 methyl magnesium bromide act as a base to abstract H plus. The second methyl magnesium bromide will attack on the cyanide. Then what happened? Then O minus, first methyl magnesium bromide, act as base. Yes, whenever there is a acidic center, Grignard reagent always act as a base first. Later it do nucleophilic addition. Here. Yes, students. Now later on he have done what is that, Nana? Hydrolysis. Due to that hydrolysis, we may get that this chlorine does not cleave off. That is OH itself is here, and now the C double bond O Me. Where is the option you see? That is C double bond O Me CH3 OH. Here is the option. Observe student. Some students are thinking that methyl magnesium bromide 2 times attack on the cyanide and we are getting carboxylic acid. No, the first methyl magnesium bromide act as a base, and the second methyl magnesium bromide only do nucleophilic addition. That's why we are getting this is the compound. You see chlorine, chlorine, C double bond O Me, CH3 and OH. So this is the question based on Grignard reagent nucleophilic addition. Now go for the next question. Yeah. This is the question based on alcohol, phenol, ether, mixed question. Sir, how it is alcohol, phenol, ether, sir? Yeah. This is the phenolic moiety. this is the ether functional group, and this is the alcohol functional group. Yeah, yes. What is it given? Very intellectual question. Product A and B represents. First you see students, this OH and OCH3 upon HBr. First the H plus attack on the ether functional group, and the Br minus will do, what is that, SN2 type of cleavage. Then we are getting this OH and this OH and methyl bromide is one thing. Next, go for the next option, that is OH and CH2OH, which on HBr. Because of double bond character, this OH cannot readily undergo nucleophilic substitution, but this is a aliphatic alcohol, this is a aromatic alcohol. This aromatic alcohol means like phenol. This can be readily substituted. Since first H plus comes attack to here, this readily substituted by Br minus. Then what happened? That is OH cannot be substituted. That CH2 and now Br will come. That is OH is undergoing nucleophilic substitution by Br minus. Now let us see the option. Where is that? Resorcinol is one option, and CH2Br and OH. Here is the option. So simply this is based on knowledge of ether cleavage and nucleophilic substitution. Go for the next question, students. Yeah, which of the following is the correct stability order of the given resonance structures? Generally, according to the resonance rules, and it comes under GOC part, general organic chemistry. Now see that resonating structures, stability of resonating structure. In all the resonating structure, the position of atom should be remains same, and the number of bond pairs and lone pairs, the total number of bond pairs and lone pairs should be remain same in all the resonating structures. According to the resonance rule, the resonating structure having more covalent bonded and all the atoms gets octet configuration except hydrogen are more stable resonating structure. If it is the charged resonating structures, the charge separation, like charges should be far away, unlike charges should be closer. Positive charge on less electronegative, negative charge on more electronegative should be the more stable. Based on the above rules, we can conclude that the structure which has all octet configuration, all the atom having octet configuration and no charge is present on the structure. That's why A should be the most stable structure. Next, go for the B. What is that? Next one is octet configuration. Just now I said chargeless structures are more stable than charged. If you go for option D and B, nitrogen 4 2s are 8 bonds, oxygen 4 2s are 8 bonds, carbon negative means here is hydrogen, don't forget the point. Here is the hydrogen, don't forget the point. So this carbon octet configuration, every atom now has octet configuration, but here still here plus is there. Still what is that? Sextet configuration, 6 electrons only present. That's why C should be the least. A should be the most stable structure due to all atoms having octet configuration, chargeless structure, and that is more covalently bonded structure. Number 2, C, it has the no octet configuration, that is why C is the least stable among this B and D. According to myself or my knowledge, that nitrogen having the positive charge, oxygen having the positive charge. Positive charge on less electronegative atom is better rather than on more electronegative atom. That's why D should be more stable than B. Based on the knowledge, A, D, B, C should be the answer for the given question. Okay, now student, now let us go for the next question. Yeah, mass percentage of nitrogen in the uracil is, if the given uracil structure in the examination, as a student it is easy. But if you won't give the uracil structure, as a student, you have to remember the structures of uracil, thiamine, adenine, guanine also be. So, if given the structure, that is the great thing for us and easy thing for us. What is the molecular formula? C4H4N2O2. This is the molecular formula of the given uracil. They asked to find out mass percentage of the uracil. Percentage of nitrogen is equal to, what you can write? Number of nitrogens into their atomic weight by total molecular weight of the compound into 100. This will give the mass percentage of mass percentage of an element in a given compound. Can you find out like this? Number of nitrogens 2 into atomic weight of nitrogen 14, molecular weight of what is that uracil 112 I think into 100. Okay students, you can get the answer is roughly 25% after doing the calculation. So mass percentage of nitrogen in the uracil, if they given the structure, very happy. If not given, you have to remember the structures. What is that for further examination? Next, go for the next question student. Yes, they given a compound X. After doing formaldehyde and base, we can expect either maybe Cannizzaro reaction or maybe aldol, crossed aldol reaction, followed by nucleophilic addition, followed by hydrolysis and heating. We can expect or reverse. First hydrolysis happen, later heating. KCN, whenever they given with carbonyl compound, we may expect that undergo nucleophilic addition followed by hydrolysis produces carboxylic acid. That carboxylic acid and again some what happened? Cyclization maybe occur, we can expect. So let us go for the options. I'll go for this option. Since they given the number of carbons is like this na, 1, what is it, 4, 5, 6, 1, 2, 3, 4, 5, 6. That is why I am trying to take this one. That is isobutyraldehyde with here is the one alpha hydrogen, formaldehyde, and in the presence of alkali. What happened? There is a crossed aldol condensation occur. Because of this crossed aldol reaction, this is the product you are getting. Say yes or no? Followed by nucleophilic addition. That H plus first protonate to speed up the reaction. These reactions are slow, catalyzed by acid catalyst. Now it become CH2OH and now it become OH and cyanohydrin forms. Now later hydrolysis. This hydrolysis causes acidic hydrolysis, carboxylic acid, and still is present as OH. Now upon heating, the OH of the carboxylic acid and the alcohol get cyclizes. Now it become, this should be the form. Yeah, whatever the form they are asking, I can get from the by applying second option. So you can apply the third option also. But it does not mention the number of equivalents. You have to do 3 times aldol condensation. After then, you may get another product also. So this is the better chance for me, that is isobutyraldehyde. I expected the answer like this. Okay, now go for the next question student. Yeah, HBr addition, this is the regular question. It is comes under hydrocarbon or addition of, that is electrophilic addition to the alkenes. Let us see students how the question is that. First here addition of HBr. Here first electrophile adds here. Always they try to form stable carbocation as intermediate. That's why I got the tertiary carbocation. This is 1, 2, 3, 4, 5. Whenever they want to write the cation or rearrangement, better to give the numbering. It becomes easier for the students to write the correct option. So this fifth carbon is shifted from or detached from the second and going to attach at first carbon. Now, which creates, carefully observe that. Otherwise, yeah, this is the second, third, fourth, and now this is the first. You see, this is the fifth going to attach here. Due to that, the second carbon gets positive charge, shifted as carbon ion. Now it becomes, for your convenience, I am writing like this. Okay, this is equal to. Now again the methyl group do the shift to get tertiary carbocation like this. Again, now the Br minus undergo addition. Now the expected product is, this should be the expected product. So where is the option? Yes, here is the option. So here the carbocation rearrangement is the major point regarding the question. Now go for the next question, student. Which of the following statement is the correct? All radicals are known as freons. No, every radical is not the freon. What is the freon? Freon is the fluorochloro derivative of methane and ethane are freons. Everyone is not the radicals or freons. Freons causes skin cancer. Freon causes skin cancer? No. Freons are chlorofluorocarbon. Yes. And freons are used in sunscreen lotion? No. These are the chlorofluorocarbons of methane and ethane. Now go for the next question, student. How many of the AgCls are formed in the given reaction? Yes, silver nitrate. Here this is triple bonded. Here this is phenyl attached. This is vinyl attached. This does not undergo substitution, or they are the stronger bonds. They cannot form any stable ion after their cleavage. So their bond energy is very high. The one and only chance here to undergo reaction is, yes, who can form stable ion? Those bonds only readily cleavable. Here this is the stable carbocation is formed. Here there is no chance of stable carbocation. The sp carbon is the most unstable carbocation. That's why it cannot loses the Cl minus, and there is a double bond character between. Here also the same double bond character. Here is also the same double bond character. Here also the vinyl carbon also having the double bond character. That's why the bond is stronger. This is the only chance to cleave off. That's why 1 mole of AgCl gets precipitated. That means the question is based on stability of the halide. Okay, now go for the next question. Yes, noradrenaline is one of the neurotransmitter. Yes, noradrenaline is one of the neurotransmitter present in your body and causes or gives mental peace. Okay, that is a tranquilizer, one of the tranquilizer which is inside or endogenous chemical which gives well-being state. That is the noradrenaline work. Therefore, noradrenaline is one of the work is tranquilizing capacity. Now, low level of noradrenaline is not the cause of depression in humans. Yes, as the noradrenaline decreases, which causes depression. He said not causes the depression is a wrong one. So noradrenaline is one of the neurotransmitter. Sir, what is a neurotransmitter? Which passes or carries the information from brain to different parts of the body and different parts of the body to what is that brain via a chemical outside the what is that nerve cell and within the nerve cell it acts as a electrical signal within the nerve cell. Outside the nerve cell it acts as a chemical. That chemical is the neurotransmitter, as noradrenaline is one of the neurotransmitter which is useful, okay, gives or useful or gives mental calmness. That is the thing. So statement 1 is correct and statement 2 is incorrect. Statement 1 is correct and statement 2 is the incorrect. Low level causes depression. This is the memory based of the student who have appeared in the examination. Student, thank you very much.